Henrietta Lacks spent her days in the tobacco fields of Southern Virginia. She was a mother of 5 children, laboring under a sun that offered very little mercy to those working the rows. When an unfamiliar, persistent pain took hold in her body, she sought help at Johns Hopkins. In 1951, it was one of the few hospitals in the region that treated Black patients. During her treatment for cervical cancer, doctors removed 2 tissue samples, one healthy and one malignant. They took this biological material without her knowledge or consent. In the lab, her healthy cells died as expected, but the cancer cells behaved differently. They multiplied over and over, ignoring the biological signals that usually trigger cellular death. Henrietta Lacks died 8 months after her diagnosis. While her physical body succumbed to disease, her cells became the foundation for a permanent, immortal line of human biology. Researchers named this line HeLa. These cells traveled across the globe, entering laboratories in the Soviet Union and the United States during the Cold War. HeLa cells provided the vital testing environment for the polio vaccine and early breakthroughs in gene editing. Modern medicine relied on her biology to advance in vitro fertilization and, decades later, COVID-19 research. This cellular line generated billions in corporate profits and launched entire industries. Yet for decades, the Lacks family remained in poverty, unaware their mother's biological essence was driving global medical commerce. Science gained a permanent resource from her body, leaving her descendants to navigate the realities of mortality without the wealth her cells created. Intrigued to test the limits of human biology, scientists eventually launched HeLa cells into orbit. They wanted to see how this resilient material would react to the vacuum of space. Earthbound biology typically fails in orbit. Without the protection of the atmosphere, zero gravity and high-energy cosmic radiation cause cellular structures to collapse. This chart tracks the HeLa replication rate. In microgravity, they did not die. They multiplied with speed and aggression, surpassing their earthbound behavior. They adapted to survive the radiation that destroys other life forms, thriving in extreme hostility. By removing these cells from the physical constraints of Earth, humanity witnessed a biological potential that no longer followed the rules of terrestrial life. Traditional planetary colonization relies on mechanical engineering. The goal has always been to use steel and heavy machinery to force alien environments to mimic Earth. The aggressive adaptation of HeLa cells in space challenged this reliance on hardware. If human tissue could thrive in orbit, the engineering focus shifted from machines to biology. Researchers began to ask if humanity could find a type of life that survives without Earth entirely, rather than forcing other planets to become Earth-like. This organic material, proving its resilience in the most extreme conditions known to science, suggests a path towards cosmic survival that hardware alone cannot provide. Every human alive today carries the mitochondrial DNA of a single vitringal ancestor. Scientists call her mitochondrial Eve, the source of the energy and continuity required for life on this planet. Trace that lineage into the future, and a second point of origin appears. Demonstrated the ability to consume radiation as an energy source, these cells could theoretically be used to break down a dead planet's minerals. Over vast periods of time, this biological presence would slowly alter the atmospheric chemistry. It turns poison into preparation, creating the potential for a breathable environment. If a new world is grown from the stolen biology of one woman, the question of ownership becomes obsolete. No corporation or government can claim a planet that is literally made of our own shared biology. Humanity enters the universe to inhabit it, not to dominate it through conquest. We return to a cosmos made possible by a woman who simply refused to die.